Next we talk about the applications of total internal reflection, in which first application is sparkling. Any application can be asked in paper, all the applications are very important. Sparkling of diamond. They said that the shape of the diamond or different faces of diamond are cut in such a way that whenever the light will incident in it, the angle of incidence should be greater than the critical angle for that particular material of the diamond, so that the ray will continuously undergoing total internal reflection inside only, and it will not be able to come out, because of which when you will see from one particular face, the emergent ray from that will show you sparkles, right? So the diamond is made up of a material whose refractive index is very large, because of which its critical angle is very small. So its faces are cut in such a way that whenever the ray enter inside it, it will be entering at an angle greater than 24.4 degree, that is critical angle. So internal reflection will take place. Next is mirage. In case of mirage, there are so many pronunciations for this mirage. So many other teachers may be using some other word. So you can call it to be mirage also. So this is actually optical illusion. Have you seen, students, that in the summers, if you are walking or standing at a road, right, and you will see at such a large distance, it appears to you if there is a wavery pond of water. It seems to you that if there is a wavery pond of water, and in that pond of water, if you will see the neighboring objects like trees, it seems to be inverted in that wavery pond of water, right? So that illusion produced on a hot summer day is called as a mirage, right? So they said that in a hot summer day, what is there? The layers of the air which are near the surface of the earth, they are quite hot as compared to topmost layers, because of which as we move toward the height above the atmosphere from the surface of earth, what we observed, that the density of the layers of air goes on increasing, because whichever are hot here, they will be lighter one, right? So density will go on increasing towards upwards. It means refractive index is also increasing toward upwards, but temperature goes on decreasing toward upwards, because these layers are mostly hotter one and they are less hotter. Topmost layers are less hotter. It means upper layers act as a denser medium and these are acting as a rarer medium. So if you are standing here and you see this tree, rays are coming from the top of the tree, they are passing from denser to rarer medium. So every time they will bend away from the normal till they fall here at an angle greater than critical angle for that particular medium, so that it will be reflected back in the same medium. Now the rays are going from rarer to denser medium, bent towards the normal. So when you will produce these reflected rays backward, it seems to you that rays are coming from here. So you are seeing this tree to be inverted one. So this is the image form of that of tree, which is inverted one. This is called mirage formation, right? So read it once and things will be more clear to you. Next very important application is total reflecting glass prisms. These are actually isosceles prisms, right? Right angled isosceles prisms. 45 degree, 90 and 45 degrees its construction. They are used for so many purposes. The reason being, if you are using something else other than prisms for reflection purpose like mirrors, so many other extra images are also formed because of the defects in the mirrors, but in prisms no such images will be formed. Secondly, mirrors are tarnished also with some material, though tarnishing processes are not there in the glass prism, so they are preferred. Secondly, in mirrors some loss of intensity is also there, but in glass prisms, if you will be able to do reflection, then there is no loss of intensity in the prisms take place. So basically prisms can be used for three purposes. They can be used to invert the image of the object, they can be used to rotate the image by 90 degree, and can be used to rotate the image by 180 degree. There are three different diagrams. See the diagrams. So all the diagrams, please you learn properly how to draw them. They are very simple. So any diagram can come in a paper as such, like they can tell you to draw the diagram for rotating or deviating the ray through 90 degree, through 180 degree, and to invert the image of the object using total reflecting prisms, right? So please go through this. Last very important application of total internal reflection is optical fibers. Very important. Have you seen in the market so many colored light lamps are available, in which if you have seen some plastic type of fibers are coming out and their bunch is tied at the bottom in a pot, and light is coming through these plastic strands till the end of each strand. That plastic fibers of which this decorative lamp made up of, that plastic fiber is called optical fiber. So through the optical fiber, light can travel from one end to the other end without the loss in intensity. So this is very important. What is the construction? How is that made up of? It actually consists of three parts: core, cladding and buffer coating. But this topic is very important. So many times it was asked in the board papers also. So the core and cladding material you have to use in such a way that the refractive index of cladding should be less than the refractive index of core. And buffer coating only provide a protection to this cladding and core surface. So this can be made up of the plastic. This is only protecting these two, core and claddings. So what will take place? This diagram will explain its working. So you can show cladding like this, double lined, and inside part is core. Where any ray of light enter from outside at this interface, it is traveling from rarer to denser medium. So it will bend towards the normal. Here inside, ray is going from core to cladding interface, mean from denser to rarer medium. So ray will strike at an angle greater than critical angle, and it will be totally internally reflected inside only, again striking at angle greater, and again total reflection will take place. A reflection will take place in this way. So it keep on traveling inside this without the loss in intensity from anywhere outside. So this is the other end of that fiber from where the light can come out, and you can see a beautiful decorative lamp lighted. So this is all about its working. So they said that one optical fiber is when joined with other, we will obtain bundle of optical fiber, which is called light pipe. So this collective light pipe is very important. It can be used in endoscopy also. So many uses are there. You read all the uses of optical fibers.